Lecture 19. The quantum enigma consciousness and reality ethereal music plays softly in background welcome to the threshold, where certainty dissolves and reality trembles beneath the weight of a conscious gaze. I am Professor, and today we venture into the quantum enigma, that bewildering realm where consciousness and physical reality become impossibly entangled. What if the very act of observation doesn't merely reveal reality, but fundamentally creates it? What if consciousness itself is not merely an emergent property of physical processes, but rather foundational to the fabric of existence itself? These are not merely philosophical musings, but questions that arise directly from the mathematical formalism of quantum mechanics itself. The quantum realm has haunted physicists for over a century with what we call the measurement problem, perhaps the most perplexing conundrum in all of science. Unlike classical physics, where objects possess definite properties regardless of observation, quantum mechanics presents us with a shadow play of probabilities, superpositions, and wave functions that mysteriously collapse when measured. This is no mere technical detail, but a fundamental enigma that strikes at the heart of our understanding of reality. Before measurement, quantum systems exist in multiple states simultaneously, suspended in a ghostly superposition of possibilities. Yet when observed, they suddenly manifest in just one definite state. How and why does this transition occur? What causes this abrupt shift from the realm of potentiality to actuality? Let us examine this wave function collapse more closely. Mathematically, quantum systems evolve according to Schrödinger's equation, a deterministic process that preserves superpositions. Yet somehow, measurement introduces a discontinuous, non-deterministic element. Consider an electron whose spin can be either up or down. Quantum theory tells us that before measurement, it exists in both states simultaneously, not merely that we don't know which, but that it literally embodies both possibilities. Upon measurement, this superposition vanishes, and we observe either spin up or spin down. The wave function, that mathematical entity representing all possibilities, suddenly collapses to a single outcome. This collapse isn't described by the Schrödinger equation. It stands outside our most fundamental theory, an unexplained rupture in the mathematical formalism. Is this collapse merely an illusion, or does it point to something profound about the nature of reality and consciousness? Erwin Schrödinger himself crafted a thought experiment to illuminate the absurdity of applying quantum superposition to macroscopic reality. You're likely familiar with his unfortunate feline thought experiment. A cat trapped in a box with a radioactive atom, a Geiger counter, and a vial of poison. If the atom decays, a quantum event governed by probability, the poison is released and the cat dies. If not, the cat lives. According to quantum mechanics, until we open the box, the atom exists in a superposition of decayed and not decayed states. By extension, the cat would exist in a superposition of alive and dead states, a notion that violates our everyday experience of reality. But what transforms this ghostly superposition into a definite state of either life or death? Is it the act of conscious observation? Does the presence of a mind somehow collapse the wave function, or does some other mechanism intervene before consciousness enters the picture? The Copenhagen interpretation, developed primarily by Niels Bohr and Werner Heisenberg, has been the dominant paradigm for understanding quantum mechanics. It posits that quantum systems don't possess definite properties until they're measured. Until then, they exist only as probability distributions. According to this interpretation, the wave function collapse isn't physical but epistemological. It represents a change in our knowledge rather than a change in physical reality. Bohr emphasized the inseparability of the quantum system from the measuring apparatus, insisting that quantum objects cannot be said to have independent properties. But the Copenhagen interpretation remains deliberately silent on the role of consciousness. It speaks of measurement without specifying whether conscious observation is necessary. This ambiguity has led some to suggest that consciousness itself might be the missing piece of the quantum puzzle. Hugh Everett's many worlds interpretation offers a radical alternative. It proposes that no collapse ever occurs. Instead, when a quantum measurement happens, reality itself branches into multiple worlds, each containing one possible outcome. In this view, when we measure the electron's spin, the universe splits into two branches, one where we observe spin-up, another where we observe spin-down. We experience only one branch, but both exist with equal reality. The wave function never collapses. It merely appears to collapse from our perspective within a particular branch. This interpretation elegantly preserves the mathematical purity of quantum theory, but at the cost of a proliferating multiverse of parallel realities. Yet even here, consciousness looms large for what determines which branch we experience. Does consciousness somehow choose its path through the quantum multiverse? Several thinkers have proposed more direct connections between consciousness and quantum mechanics. The quantum mind hypothesis, advanced by physicists like Roger Penrose and Stuart Hameroff, suggests that quantum processes in the brain, perhaps in neural microtubules, might be essential to consciousness. Perhaps the most provocative interpretation comes from John von Neumann and Eugene Wigner, who proposed that consciousness itself causes wave function collapse. In this view, the chain of entanglement extends from quantum system to measuring device to human observer, with collapse occurring only when the result enters conscious awareness. As Wigner wrote, it follows that the quantum description of objects is influenced by impressions entering my consciousness. If true, this would place consciousness not at the periphery of physics, but at its very heart, an idea as revolutionary as it is unsettling. The double-slit experiment remains our most profound window into quantum weirdness. When electrons or photons pass through two adjacent slits, they create an interference pattern on the detector screen, behaving as waves that pass through both slits simultaneously. Yet when we attempt to determine which slit each particle passes through, the interference pattern vanishes and the particles behave as discrete objects. Somehow, our very act of looking transforms the fundamental behavior of matter. Even more bizarre are quantum erasure experiments, where information about the particle's path is first recorded, then erased after the particle has already passed through the slits. Remarkably, this retroactive erasure restores the interference pattern. It's as if present actions can influence past events, or perhaps more accurately, as if the very concept of a definite past dissolves in the quantum realm. These quantum mysteries cast long shadows across philosophy. The materialist worldview, that matter is primary and consciousness secondary, finds itself challenged by a physics in which observation plays a constitutive role in reality. Perhaps the hard problem of consciousness, how physical processes give rise to subjective experience, has been approached backward. What if consciousness is not an emergent property of matter, but fundamental to reality itself? What if matter and the physical world are what emerge from a deeper realm of consciousness or information? Quantum theory doesn't definitively answer these questions, but it opens doorways to possibilities that classical physics foreclosed. It hints at a reality far stranger and more mind-like than we've imagined. A reality in which the boundary between observer and observed becomes permeable, perhaps even illusory. We stand before an abyss of mystery, where the foundations of physical reality and conscious experience seem to merge. The quantum enigma remains unsolved, perhaps even deepening with each new experiment and theoretical advance. Are we merely witnesses to an independent reality? Or are we participants in a cosmic dance where consciousness and matter mutually create each other? Could it be that the universe itself is not a thing but a process, a vast network of information exchange in which consciousness plays a fundamental role? As we conclude, I leave you not with answers, but with questions that ripple outward toward the horizon of human understanding. Perhaps the true nature of reality is neither purely physical nor purely mental, but something that transcends this ancient dichotomy, something we can glimpse only in the mysterious mirror of quantum theory. Until next time, I invite you to dwell in this mystery, to let the quantum enigma work upon your imagination. For it is in the spaces between certainties that the most profound insights often emerge. Ethereal music fades.